In Chapter 10, we looked at several different functions and how they move or translate. So for the warm-up, sketch and label the following functions. So the first is the square root of x, and if you remember, it looks something like this. So here's y equals the square root of x. Let's erase that. Then we have y equals negative the square root of x, and if you forget any of these functions, you can type them in. So if I go to graph, here's the square root of x. There's that first one that I graphed. Let's try the next one. So let's say you didn't know what the negative did on the outside. So I'm going to hit tab. Oops, I have to be here. Tab. I'll put a negative and then a square root of x. And you can see if the negative's on the outside, it reflects it over the x-axis. So let's make ours red like theirs. So it looks something like this. And the last one, if the negative's on the inside, what does that do to the graph? Again, if you don't know, we can type it in, control x squared, negative x, and that reflects it over the y-axis. Okay, so this is y equals square root of negative x. Okay, let's go to review of different functions that we've looked at this year. And I'm going to make this a little bit smaller so we can see all 4 of them. So the first one is a straight line. So this is a linear function. And we've looked at, let's see if this will work here. Let me quit here. There we go. All right, so if it's linear, we have the equation y equals mx plus b. Here's the parent function. This is just y equals x. If it's quadratic, that's when we have x squared as the highest power. Absolute value is when we have those lines here. It's distance from 0. And again, we just looked at the square root function, y equals the square root of x. So these are the different parent functions that we looked at in Chapter 10, and we looked at shifting them up, down, left, and right. And also we looked at the slope or how they reflect. So general rules on how they shift. If it's on the inside of the parentheses, the square root, or the absolute value, if it's on the inside, that's when it shifts left or right. So minus would be to the left. So here the minus 3 is left 3. If it's on the outside of the absolute value, square root, or parentheses, it's up or down. So the plus 5 here is up 5. Right here, the plus 6 would be, oh, sorry, this is not left 3. This is right 3. It's opposite of what you think. So this should be right 3. The plus 6 would be left 6. The minus 11 would be down 11. The minus 3 on the inside, again, would be right 3, and the plus 15 would be up 15. So on the inside of the parentheses absolute value or square root sign, it's left or right. It's the opposite of what you think. Minus is to the right, plus is to the left. And on the outside, it's what you think. The plus is up and the minus would be down. So knowing that, let's sketch the following functions. So it's a square root function which starts at 0, 0, but then it's going to go plus 3 would be to the left 3 and up 2. So left 3, up 2. Here's a sketch of that function. Here it's minus 3 would be to the right 3, down 5. And the slope, that a value there, that negative 2, be negative 2. So we're going to go right from 0, 0, go right 3. We're going to go down 5. And the slope is negative 2, so we're going to go down 2 over 1 in each direction and draw our line. So it looks something like that. Let's take a look at C. Let's make this a little bit bigger here. Okay, so C plus 4 would be left 4. Plus 3 would be up 3. And the negative would mean your slope would be negative or be upside down. So here we start at 0, 0. We're going to go left 4, up 3, and then you're going to sketch your parabola be upside down. And the last one, the -1 would be to the right 1. -3 would be down 3. And then the slope here would be 1 over 2, this number on the outside. So we're going to go right 1, down 3, and slope of 1/2, go down 1 over, positive 1, so go up 1 over 2. Up 1 over 2, there's one direction. Up 1, go to the left now. Up 1 to the left, 2. So it's wider than the original graph. So there's a look at graphing these shifted functions. Let's go backwards. Let's write the equation of the shifted function. So we know this is a square root. We know it should have started at 0, 0. So this one goes left 2, up 1. So I'm going to write that down. Left 2, up 1. So we have y equals the square root of x plus 2. Let's do that better. Plus 1. Let's take a look at the other function here. I can't read that. Okay, so this goes to the right 3, down 4, and what's our slope here? It looks like it goes, this is 1 right here, over 1, up 1, nope, over 1, up 2, there we go, over 1, up 2. So it's a little bit narrower than the original, so the slope is 2. So you have y equals 2 times the absolute value, because it's v-shaped. Right 3 would be x minus 3, and then minus 4. So here's the equation of the line right here. And we have some parabolas here. Again, they start at 0, 0. This one goes to the left 4, up 3, so and it's upside down, so y equals negative. Left 4 would be x plus 4, the squared makes it a parabola, and then up 3. And then again, the minus makes it go upside down. And the last one's just up 1, so y equals x squared plus 1. And then remember, if you have that number in front, if the number is less than 1, so 0.75, this is going to be wider or fatter. I'll put F for fatter. This will be skinnier. The 0.5 will make it fatter, and the -4 will make it skinnier and upside down. And a quick review of trig. Remember Pythagorean theorem, a squared plus b squared equals c squared. You have your special right triangles. And then we had SOHCAHTOA, solving for sides, you cross multiply, and solving for angles, take the inverse.